solve Leetcode problem 3249, count the number of good nodes. So for this problem, we are giving the edges, and the length of the edges is going to be n minus 1 because we are giving the undirected tree with n nodes labeled from 0 to n minus 1. Yeah. So we are going to return the number of good nodes in the given tree. So what is a good node? So for example, this node 0 is a good node because it has two subtrees, and how many nodes for its subtrees? It is 3 left subtree, and how many nodes at the right subtree? It is also 3, so that is why it is a good node. So in the same way, all those nodes are good nodes. So in total, it's going to be so in total it's going to be 7. Yeah. So in the second example, it's going to be 6. Yeah. So for this node, left and right, it is both 0. So this means it is true. And also for this node 6, 7, 8, and 3. At the left side, there's one node. At the right side, there's also one node. And for this node 4, it is a leaf node. So we're going to count it. So in total, it's going to be 6. And in this example, it's going to be 12. As we can see, all those blue colored circles that are good nodes. Yeah. So how can we solve this problem easily? And because this is an undirected graph problem, so first of all, we're going to turn this undirected tree into a graph, and then we just need to traverse the graph. Yeah. Let me prepare a graph. It's going to be a default undict, and it's going to be a list inside. Yeah. And for AB inside the edges, let me just prepare the graph first. Yeah. So it's going to be GA append with B, and GB gonna append A. So this is an adjacency list. That is what we need. Now we're gonna define DFS function to check. So we're gonna use something like traversal of the tree to check. So for example, this is the first node. So we're gonna check its left child and its right child. So if the number of the nodes from the left tree is equal to the number of the nodes for the right tree, so we're gonna count this one gonna be true. So we're gonna count it as 1. Yeah. So we're gonna start from the current index I, and we're gonna prepare a parent. So we're gonna call it father. Yeah. So we're gonna call this. We're gonna prepare a self.result. It's gonna be 0 from the beginning. Then we're gonna call the DFS. So it's gonna start from the 0 index. So it means this child. Because our graph, we need to start from the 0 node. So we're gonna use the 0 node as our first node to traverse for the tree. Yeah, or for the graph. And our father or parents is gonna be -1. After calling the DFS, we're gonna return the self.result. So self.result is gonna be how many good nodes. Yeah. Now we just need to finish the function here. So let me just use the first node as x. Yeah. So for y in dx. So if it's a child y equal to its father. So we're gonna continue. Yeah, so this means basically we want to traverse the graph as a tree. We cannot go back. Yeah, so according to this way, first of all, the father from the beginning is -1, and this is our x. It is node 0, so its children is 1. Definitely this one is not equal to its father because its father is -1. Yeah, definitely we don't want to produce a loop, so this is why we're gonna check it. So if it's a child equal to father, definitely we want to continue. Yeah, but before that, let me just prepare some variables. So we're gonna prepare size maybe, and we also want to prepare the first size for the first subtree. We're going to prepare first size. That is going to be the size for the first subtree for the current root node. And we're going to prepare a flag. Yeah. So the size we're going to prepare as 1, and the first size let me prepare it as a 0 because we are not sure currently, and the flag let me give a true. Yeah, so the size is set as 1 because for the child node, yeah, for the child node, if it is a leaf, so for example this 5 and 6, if it is a leaf, so the size is going to be 1. Yeah. Now we're gonna calculate the size. It's gonna be the DFS. It's gonna be the y and its father gonna be x. So currently we're gonna call this DFS. It's gonna be this DFS with 1 and its father gonna be 0. So definitely we wanted to count the size of this subtree. So we're gonna call it as size. Now we're gonna check this size. If this size is equal to the first size, not equal. Yeah, if this is a yeah, let me just use. If the first size is equal to 0, yeah. So this means we're gonna prepare our first size. So the first size is gonna. Yeah, because from the beginning, the first size we set it as 0. So if it is 0, so our first size is gonna be this size. So this size, yeah. So our first size is gonna equal to the size because it is from the 0 from the beginning. This is what we prepared before. So this is gonna be the first size. Yeah. So elif first size. Yeah, elif this means that the first size are not equal to 0. Yeah, but elif this is first size not equal to 0, but this first size is not equal to our current size. Yeah, so I'm gonna call it as a size. If it's not equal to our current size, so what's gonna happen is we're gonna set the flag to a false. So this means basically we don't want to count it. Yeah. So for here, after the for loop, we're gonna update the self.result. It's gonna plus equal to the flag. Yeah, because this flag, if it is true, it's gonna plus a 1. If it is false, it's gonna plus a 0. So finally, for the DFS, we're gonna return the size. Yeah. So what is the size of the tree? Basically, we need to yeah, we need to plus this size. We need to use the size of yeah, we need to use this size for this node and plus all its children. So what is its children? So from here, yeah, so from here we need to use the size because we need to get the size of the tree. It's gonna plus equal to its children, and it's gonna be the size. Yeah, so this is going to be the size of the tree. So for example, for this node 0, so the size is going to be 7. But we're going to check the left and the right side. It's going to be equal, so we're going to plus a 1. Yeah, so this is the DFS function. Let me just run it to have a check. As you can see, it works. I'm not sure what's going to be the easiest way to write this function, but according to the description, the easiest way to write is we just use a parent as father and current node, and we're going to start from 0 with -1. And then we're going to check this is continue. Yeah, this is the basic writing. Now we're going to check the size. Yeah, maybe you will not use the self.result at the moment, but finally you need to record the self.result. Here we're going to use a flag. If the flag is true, we're going to plus a 1. If the flag is false, we're going to plus a 0. Yeah. So this means while we are traversing the tree, it's going to be O(n) time. N going to be 10 to the power of 5. By using this O(n) time, actually we've already get the final result. It's going to be the self.result. Yeah. And for each of the DFS, actually from here, so for this node 0, we've already get the result. While we are checking, for example, this node 1, yeah, we also get the result. But before we get the result, we have already updated the self.result. Yeah, so this is why actually this problem is like a post-order traversal. So we're going to first check all its children, and then we're going to check the root node. Yeah. If you know something about post-order traversal, so basically you can write this kind of a function to solve the problem. Yeah. Now let me just run it to check if it works. Yeah, now as you can see, it works and it's pretty fast. Thank you for watching. See you next time.